In this lesson, we're going to look at some applications of trigonometry. So finding some equations of tangent lines, finding some maximum minimum values, finding some inflection points, concavity, and a word problem. So before we start that, let's just review finding exact values of a trig ratio. So let's find the exact value of tan of 5/3. So if you remember, we first would like to draw a diagram. So 5 pi over 3 would be in quadrant 4. So think of 1/3, 2/3, 3/3, 4/3, 5/3. So it is over here. So what that means is I've created a pi over 3 triangle, and that comes from 2 pi to go all the way around minus 5 pi over 3 is pi over 3. So that's my related angle. So then I think of my special triangles. Special triangles, the sides would be 1, root 3, and 2, and then just check the signs. In quadrant 4, x is positive, y is negative. So there's my diagram. Once I have the labeled diagram, I can just find tangent. So tangent is opposite over adjacent, so it is negative root 3 over 1, or just negative root 3. So that's the process you would go through to find exact values of sine, cosine, or tan ratios and the reciprocals, so secant, cosecant, and cotangent. Okay, in question 2, we want to find the equation of the tangent line to the curve y equals sine x minus cos squared x. Oh, I'm missing something. We need a point. So at x equals 5 pi over 4. So let's first find the point. We're going to have to find a point that's on this tangent line. So let's just find a point. So we want to find it at x equals 5 pi over 4. So I'm just going to sub that in here. So I've got sine 5 pi over 4 minus cosine 5 pi over 4 squared. So 5 pi over 4 would be all the way over here, which is pi over 4 past pi. Those sides would be 1 root 2, and both x and y would be negative in quadrant 3. So sine of 5 pi over 4 is opposite over hypotenuse, so that's negative 1 over root 2, minus cosine of pi over 4 is adjacent over the hypotenuse, so negative 1 over root 2 as well. So we have negative 1 over root 2 plus 2 negatives make a positive, plus 1 over root 2 all squared, which is just 0. So the point it's going to pass through is 5 pi over 4 and 0. So let's just get that out of the way. Okay, so once we've done that, we want to find the slope of the tangent. Remember, we're trying to find, we want the equation of a tangent line, so we want y equals mx plus b. So m will be the slope of the tangent line. So in order to find the slope, we want to find the derivative of sine x minus cos x all squared. So this is the chain rule. So we'll bring down the 2. The inside stays the same. 2 minus 1 is 1. Then we're going to find the derivative of the inside. So the derivative of sine x is cosine x, minus the derivative of cosine x is minus sine x. So I'm just going to make these 2 a negative, and a negative is a positive. Okay, so what could we do with this? Well, we could expand these brackets. So we're going to get sine squared x minus cos squared x, because we have a difference of squares, right? So we've got sine x times sine x is sine squared x. We've got sine x cos x minus sine x cos x, so that's 0, and then we have cosine times cosine is cos squared x. Okay, so this is the slope of my tangent line, and we want to find it at the value x equals pi over 4. So you could have subbed that pi over 4 in. You didn't have to expand. You could still put it in. It just means I only have to sub it into 2 spots instead of 4. Let's put prime at pi over 4. So sine of pi, so we've got sine of pi over 4, which is going to be squared, minus cosine of pi over 4, which is also going to be squared. Oh, sorry, it's 5 pi over 4. Okay, so we already know that sine 5 pi over 4 is negative 1 over root 2. We already determined that earlier. And cosine is also negative 1 over root 2. So that's going to be 1/2 minus negative 1 over root 2 squared is also 1/2. So that's going to be 2 times 0. So the slope of the line is 0. So y equals 0x plus b. And it's going to be through the point 5 pi over 4 and 0. So we'll put in 0 for y, 5 pi over 4 for x, and b will be 0. So the equation of the line is actually y equals 0x plus 0, or y equals 0. So that would be a horizontal line with a slope of 0. Okay, in this question we want to find the maximum area of a right triangle. So this application is a word problem. So it's an optimization question like we did in Unit 16. So maximum area of a right triangle with hypotenuse length 10 root 2. So let's just draw a diagram of a right triangle. The hypotenuse is 10 root 2. Area of a triangle is base times height divided by 2. So we've got a base and we've got a height on this triangle. So what I'm going to do, I want to find the maximum area. So I only want, I want to put this in terms of sine and cosine. So if this angle's theta, cosine of theta would be the adjacent side over the hypotenuse, and sine of theta would be the opposite side over the hypotenuse. So I'm going to isolate for b, and I'm going to isolate for h. Let's put these, you know what, let's put the 10 root 2 at the beginning. This makes it a little neater. Okay, so b is 10 root 2 cosine theta, and h is 10 root 2 sine theta. So that allows me to substitute these into the base, or the area formula. So 1/2 base, so I'm going to replace the base with 10 root 2 cosine theta, and the height with 10 root 2 sine theta. So this allows me to express area in terms of theta, and then I can find theta. Okay, so that's like my x. So I have it in one variable, which is theta. I'm just going to tidy up this equation a little bit. So I'm going to multiply 10 root 2 times 10 root 2 times 1/2. So 10 times 10 is 100. Root 2 right times root 2 is 2. 2 times 1/2 is 1, so it's just 100. So 100 cosine theta sine theta. Okay, so we want to maximize the area, so we're going to find the derivative of area. So it's going to be 100. And then we have cosine times sine, so we have a product. So we'll take the derivative of cosine, which is minus sine theta, times sine theta, plus cos theta times the derivative of sine theta, which is cos theta. So that leaves us with cosine times cosine is cosine squared, and minus sine squared. So we want to maximize this. So we're going to set, the 100's not going to make a difference, so we're going to set the factor cos squared theta minus sine squared theta to 0. We want to solve for theta. So we have two variables. We have cosine and sine, or two unknowns. So I'm going to put the sine squared to the left to make it positive. And what I'm going to do is, and this is something that's, you might not think of, but what we can do is we can divide both sides by cosine squared theta. And what that does is cos squared theta divided by cos squared theta is 1. So that kind of eliminates that cos squared theta, because now it's just 1. And then I know that sine over cosine is tan, so I can change this to tan squared theta. And so what I've done is I've gone from two unknowns, cosine and sine, to just tan. So now I can solve for theta using tan. So tan, I'm going to square root both sides, would be plus or minus 1. But if I use my cast rule, I can only use quadrant 1 because the question says it's a right angle triangle. So I'm limited to the value of theta. So theta must be less than 90 degrees because it is a right angle triangle. So it's only going to be in quadrant 1. So in quadrant 1, tan is 1 when we have a triangle that is a related angle pi over 4, because we have 1 over 1. So theta is going to be pi over 4 in quadrant 1. So now I can go back to my area equation, which was 100 cos theta sine theta, and I can put in cosine of pi over 4 and sine of pi over 4. And cosine of pi over 4 is 1 over root 2. Sine of pi over 4 is also 1 over root 2. So that gives me 100 divided by 2, which is going to be 50. There were no units given, so I'm just going to put units squared.